Integration of Autonomous Weapon Systems by 2025, a report on critical development phases and global investments. Overview. The global landscape for military technology is rapidly evolving, particularly with the anticipated integration of Autonomous Weapon Systems (AWS) by 2025. This integration is projected to involve significant advancements across 4 critical development phases and is supported by an estimated $1.8 billion global investment. This report synthesizes insights from various sources to outline the current state and future directions of AWS integration, focusing on technological advancements, strategic implications, and projected timelines. Key development phases. 1. Research and Development (R&D). The first phase of AWS integration focuses on refining algorithms and enhancing machine learning capabilities that empower autonomous systems to make decisions in combat scenarios. This is a foundational step to develop AWS capable of operating independently while adhering to international laws and ethical standards. Key areas of focus include developing advanced AI algorithms that can analyze battlefield data in real time, ensuring compliance with international humanitarian law and ethical guidelines, exploring collaborative models for human-machine interaction to ensure accountability and oversight. 2. Testing and validation. The second phase involves rigorous testing to evaluate AWS performance and reliability in both simulated and real-world environments. This critical phase aims to ensure that these systems can navigate complex battlefield dynamics, including unpredictable human actions and environmental changes. Key components of this phase include conducting extensive field tests to assess system effectiveness and safety, developing metrics for evaluating AWS performance against human operators, gathering data on system responses to various combat scenarios to refine algorithms. 3. Integration into military operations. After successful validation, AWS will be integrated into existing military frameworks. This phase will emphasize establishing effective human-machine teams, ensuring that AWS augment rather than replace traditional military forces. Important considerations include training personnel to work alongside AWS effectively, creating protocols for operational command and control that incorporate AWS, ensuring interoperability with existing military systems and technologies. 4. Deployment and assessment. The final phase encompasses the actual deployment of AWS in operational settings, allowing for real-time assessment of their effectiveness in combat situations. Continuous feedback loops will be essential for ongoing development and refinement. Key aspects include monitoring and evaluating AWS performance during real engagements, adjusting operational strategies based on performance data, implementing lessons learned into future R&D and operational practices. Common key points. Investment and economic impact. The projected global investment of $1.8 billion underlines the urgency and importance of advancing AWS technologies. This investment signals a broad consensus among defense sectors worldwide regarding the potential of AWS to significantly enhance military capabilities. Technological advancements. The integration of advanced technologies such as artificial intelligence and machine learning is critical for enabling AWS to make autonomous decisions while adapting to rapidly changing combat conditions. These advancements will drive the development of intelligent systems capable of learning from experiences and making data-driven decisions. Ethical and legal considerations. The deployment of AWS raises significant ethical questions regarding accountability in warfare. There is a growing recognition of the need for a robust framework to guide the ethical deployment of these systems. Addressing concerns about decision-making in life and death situations and the potential for unintended consequences. Differences between sources. Various sources emphasize different aspects of AWS integration. For instance, while some focus on technological advancements and economic implications, others, such as Alexia Maddox's LinkedIn post, highlight sociological impacts and the necessity for frameworks governing human decision-making in defense applications. One source discusses the technological advancements related to wireless infrastructure, suggesting a broader technological ecosystem that supports AWS development, while another source addresses the socio-technical implications of autonomous warfare, emphasizing the need for a balanced approach to technology and human oversight. Timeline of events: 2022 to 2023, initial R&D activities and foundational testing phases commence as defense contractors and military organizations begin investing in AWS technologies. The focus is on developing core competencies in AI and machine learning. 2024, extensive testing and validation of AWS capabilities are expected to culminate in the first pilot programs that integrate AWS into military operations. This year will be critical for assessing the readiness of AWS for operational deployment. 2025, full-scale deployment of AWS is anticipated, with ongoing assessments and modifications based on battlefield performance data. This year will mark a significant shift in military operations as AWS become integral to combat strategies. Conclusion: the integration of autonomous weapon systems by 2025 represents a multifaceted endeavor characterized by technological innovation, substantial investment, and critical ethical considerations. The success of this integration will depend on the effective collaboration between humans and machines, ensuring that these advanced systems enhance military effectiveness while maintaining accountability and compliance with ethical standards. As the military landscape evolves, the implications of AWS integration will extend beyond the battlefield, influencing global security dynamics and raising essential questions about the future of warfare. In summary, the path towards integrating AWS into military operations is marked by strategic planning, rigorous testing, and a commitment to ethical standards, all of which will shape the future of defense in an increasingly autonomous age. The content provided outlines the integration of autonomous weapon systems AWS by 2025, detailing four critical development phases supported by a global investment of $1.8 billion. However, several counterintuitive points can be derived from the information. 1. Human-machine collaboration versus replacement. A counterintuitive aspect is the notion that AWS are intended to complement rather than replace human forces. While there is widespread concern regarding automation in warfare leading to a reduction in the need for human soldiers, the focus on creating effective human-machine teams suggests a paradigm shift where human judgment remains crucial even in increasingly automated environments. This implies that despite technological advancements, the role of human operators will not diminish as expected, rather it will evolve to become more nuanced, requiring enhanced skills for collaboration with intelligence systems. 2. Ethical frameworks and accountability. Another surprising element is the recognition of the ethical and legal implications of AWS. While one might assume that the military's primary focus would be on operational efficiency and technological prowess, there is an emphasis on developing robust ethical frameworks to govern the deployment of these systems. This indicates a growing awareness and responsibility among military planners and technologists regarding the potential consequences of autonomous warfare, suggesting a cautious approach that contrasts with the often aggressive push for technological supremacy in military contexts. 3. Investment motivation. The substantial $1.8 billion investment might initially suggest a rush to deploy AWS as quickly as possible. However, the phased approach emphasizing R&D testing and validation indicates a more deliberate and cautious strategy that prioritizes safety and effectiveness over speed. This reflects a counterintuitive understanding that the path to military enhancement via automation is fraught with complexities that require thorough examination and careful integration into existing military frameworks. 4. Technological dependence and vulnerability. While advancements in AI and machine learning are often celebrated for enhancing operational capabilities, they also introduce vulnerabilities. The reliance on sophisticated technologies for decision-making in combat scenarios may create new risks such as susceptibility to hacking or system failures in critical moments. This raises a counterintuitive concern that although AWS may enhance military effectiveness, they could also compromise operational integrity if not managed properly. 5. Sociological implications versus technological focus. The divergence in focus between technological advancements and sociological impacts is noteworthy. While many discussions surrounding AWS center on their technical capabilities, the insights from sociologist Alexia Maddox highlight the importance of understanding the broader societal implications of deploying these systems. This suggests that the integration of technology in military applications is not just a technical challenge but also a social one where public perception, policy, and ethical considerations play pivotal roles. 6. Timeline and real-world application. The anticipated timeline of AWS deployment suggests a rapid evolution of military technology. However, the actual integration into operations may reveal a slower adoption rate than predicted. The complexities of real-world combat conditions combined with the need for extensive training and adaptation of existing military personnel to work alongside autonomous systems could lead to delays that contradict the optimistic projections for 2025. In conclusion, the integration of autonomous weapon systems by 2025 reveals several counterintuitive insights that challenge conventional thinking about the role of automation in warfare. Rather than a straightforward replacement of human capabilities, the integration process emphasizes human-machine collaboration, ethical considerations, and the sociological impacts of technology in defense applications. These complexities underscore the need for a careful and deliberate approach to the deployment of AWS. Balancing technological advancements with the realities of human involvement and societal implications. The report on the integration of autonomous weapon systems AWS by 2025 presents a comprehensive overview of the critical development phases and the anticipated global investment of $1.8 billion. While the summary captures several key points, there are nuanced aspects of the report that many may overlook, yet they hold significant implications for the future of military operations and ethical considerations in warfare. Important overlooked content. 1. Human-machine collaboration. One of the most crucial aspects often glossed over is the emphasis on human-machine collaboration during the integration of AWS. The report highlights the intention to create effective human-machine teams, but it does not delve deeply into the psychological and operational challenges that may arise. Understanding how human operators will interact with AWS is vital as it encompasses trust in machine decisions, potential cognitive overload, and the impact of machine autonomy on soldier morale and decision-making processes. The success of AWS will depend not just on technological advancements but also on how soldiers and commanders adapt to these new systems in high-stress environments. 2. Ethical framework development. The ethical considerations surrounding AWS are mentioned, but the report does not provide an in-depth analysis of what constitutes a robust framework for ethical deployment. Many stakeholders, including military personnel, policymakers, and civilians, will have differing perspectives on accountability and moral responsibility in autonomous warfare. The development of such a framework is significant as it will guide the operational use of AWS and shape public perception and acceptance. Overlooking this aspect could lead to significant backlash and ethical dilemmas in military engagements. 3. Impact on global military balance. The report mentions a $1.8 billion global investment in AWS, signaling a broad consensus on their military potential. However, it fails to address how the integration of AWS will alter the global balance of power. Countries that successfully integrate and deploy AWS could gain a competitive advantage, leading to an arms race in autonomous technologies. This shift could exacerbate geopolitical tensions and provoke reactions from nations that may feel threatened. Understanding these dynamics is critical for policymakers and military strategists. 4. Long-term societal implications. The integration of AWS is not merely a technical endeavor, it has profound societal implications that the report does not fully explore. The normalization of autonomous warfare could desensitize societies to the realities of conflict, leading to a potential increase in military interventions. Furthermore, the report does not consider the implications for veterans and those affected by the introduction of these systems. The psychological impacts on operators who may be replaced or augmented by AWS. And the societal perception of warfare as more detached and less human are areas that warrant further exploration. 5. Environmental and logistical considerations. While technological advancements are discussed, the environmental and logistical challenges associated with deploying AWS are overlooked. The energy demands, maintenance requirements, and infrastructure needed to support AWS operations could significantly influence their effectiveness and sustainability. As militaries move towards more autonomous operations, the environmental footprint and resource allocation for these systems will become critical factors that affect strategic planning. 6. Cultural resistance to technology. The report does not adequately address the potential cultural resistance within military institutions to adopting AWS. Changes in technology often face pushback from personnel accustomed to traditional warfare methods. Understanding the cultural dynamics and possible resistance to integrating AWS into military operations is essential for ensuring smooth transitions and effective training programs. This cultural aspect is significant as it can affect the speed and success of AWS integration. Conclusion. The integration of autonomous weapon systems by 2025 presents a complex interplay of technological, ethical, and societal dimensions that extend beyond mere advancements in military capabilities. The overlooked content in the report, ranging from human-machine collaboration and ethical frameworks to geopolitical implications and cultural resistance, underscores the multifaceted nature of this integration. Addressing these aspects is crucial for ensuring that the deployment of AWS is not only effective but also responsible and reflective of the values of the societies they are designed to protect. As nations invest heavily in these technologies, a comprehensive understanding of their broader implications will be essential for sustainable and ethical military practices in the future. 1. Research and development. R&D is a foundation for AWS integration. The R&D phase is critical in establishing the technological underpinnings of autonomous weapon systems (AWS). The focus here is on refining algorithms and enhancing machine learning capabilities for autonomous decision-making. This phase not only influences the operational effectiveness of AWS but also shapes compliance with international laws and ethical standards. Therefore, an in-depth analysis should explore current advancements in AI and machine learning, their implications for operational autonomy, and the necessity of developing robust ethical frameworks to govern their use in warfare. 2. Testing and validation. Ensuring reliability in combat scenarios. The testing and validation phase is essential for confirming the reliability and performance of AWS. This involves extensive simulations and real-world trials to evaluate how these systems adapt to complex battlefield dynamics, including unpredictable human behaviors. A discussion on this topic should analyze the methodologies used for testing AWS, the challenges faced in simulating real-world conditions, and how these systems can be optimized to work effectively within the unpredictable nature of combat. 3. Ethical and legal considerations in autonomous warfare. The deployment of AWS raises significant ethical and legal questions, particularly regarding accountability in warfare and the potential for unintended consequences. An in-depth discussion should address the ethical dilemmas posed by autonomous systems making life-and-death decisions and the need for a comprehensive legal framework that governs their use. This includes exploring perspectives from various stakeholders such as military leaders, ethicists, and policymakers, as well as examining existing international laws on the use of force and their applicability to AWS. 4. Investment trends and economic impact on military capabilities. the anticipated global investment of $1.8 billion in AWS technology underscores the strategic importance of these systems in modern military operations. An analysis of investment trends should encompass the economic implications of integrating AWS into military frameworks, the potential for cost savings, and the long-term impact on defense budgeting and procurement. Additionally, it would be valuable to explore how this investment aligns with broader geopolitical strategies and the competitive landscape of global defense technologies. These 4 points provide a comprehensive foundation for in-depth analysis and discussion on the integration of autonomous weapon systems by 2025, highlighting technological, ethical, and economic dimensions of this critical development in modern warfare. 1. The Manhattan Project 1942–1946. The Manhattan Project was a secret U.S. government research project that developed the first nuclear weapons during World War II. This initiative involved extensive research and development phases where scientists worked on refining complex nuclear fission processes. The project faced significant testing and validation phases, culminating in the use of atomic bombs on Hiroshima and Nagasaki in 1945. The ethical implications of nuclear warfare and the accountability for the consequences of deploying such destructive technology remain subjects of ongoing debate. 2. The development of the drones in warfare 2000s present. The integration of unmanned aerial vehicles (UAVs), commonly known as drones, into military operations represents a significant evolution in warfare technology. This development has involved multiple phases, including research into remote piloting, testing for operational reliability, and gradual integration into military strategies, particularly in surveillance and targeted strikes. The use of drones has raised ethical questions regarding remote warfare, the implications of automated targeting, and the accountability of operators and military leadership in drone strikes. 3. The introduction of the Internet in military communications 1990s. The evolution of the Internet and its application in military communications during the 1990s transformed how militaries around the world operated. This integration involved phases of research and development of networking technologies, extensive testing of secure communication protocols, and gradual incorporation into military operations. The introduction of Internet technologies brought about strategic advantages in information warfare, logistics, and command and control systems. However, it also raised concerns regarding cyber warfare, data security, and the ethical implications of military operations conducted through digital means. Future outlook: integration of autonomous weapon systems by 2025. The integration of autonomous weapon systems (AWS) by 2025 is poised to transform military operations significantly. This transformation will occur through 4 critical development phases underpinned by a substantial global investment of $1.8 billion. Below we provide a future outlook, predicting the implications of these developments. 1. Research and development (R&D) phase. Predictions. Enhanced algorithms. By 2023 we expect substantial advancements in machine learning algorithms, allowing AWS to process vast amounts of battlefield data in real time. This could result in systems that can make tactical decisions more efficiently than human operators. Interoperability. Continued R&D will focus on ensuring AWS can communicate seamlessly with other military systems, enhancing situational awareness. This will lead to the development of integrated platforms that can share intelligence and coordinate actions autonomously. Potential impact. Operational efficiency. Enhanced algorithms will lead to faster decision-making processes, potentially reducing casualties and material losses in military engagements. The ability to analyze scenarios with multiple variables will allow AWS to operate effectively in complex environments. 2. Testing and validation phase. Predictions. Simulation advancements. By 2024, military organizations will employ advanced simulation technologies to test AWS in various combat scenarios. These simulations will replicate not only physical conditions but also psychological factors such as unpredictability in human behavior. Compliance and safety protocols. Efforts will be made to establish rigorous testing standards that ensure AWS operate within legal and ethical guidelines mitigating risks associated with autonomous decision-making. Potential impact. Public acceptance. Successful testing and validation phases will be critical in fostering public trust in AWS. If these systems demonstrate reliability and adherence to ethical standards, acceptance among military and civilian stakeholders may increase. 3. Integration into military operations phase. Predictions. Human-machine collaboration. By late 2024, experiments with human-machine teams will become commonplace, with AWS augmenting human capabilities rather than replacing them. This collaborative framework will be essential for effective military operations. Training protocols. Development of new training programs for military personnel will focus on interacting with and managing AWS. This training will emphasize understanding the limitations and capabilities of AWS. Potential impact. Operational redefinition. The integration of AWS will redefine the roles of military personnel, creating hybrid teams where human intuition and machine efficiency coexist. This shift could lead to more strategic applications of force and resource allocation. 4. Deployment and assessment phase. Predictions. Real-time adjustments. By 2025, AWS will be deployed in operational settings with the capability for real-time adjustments based on battlefield feedback. Continuous learning mechanisms will allow these systems to adapt and refine their tactics. Performance metrics. Militaries will establish comprehensive metrics to assess the effectiveness of AWS, focusing on their impact on mission success rates and operational costs. Potential impact. Data-driven warfare. The deployment of AWS will usher in an era of data-driven warfare where analytics will play a crucial role in shaping military strategies. This reliance on data may lead to more precise targeting and reduced collateral damage. Common trends and considerations. 1. Investment and economic implications. The projected $1.8 billion investment reflects a growing recognition of AWS's potential to revolutionize military capabilities. This financial commitment will spur further innovation and competition among defense contractors globally. 2. Technological integration. The incorporation of AI, machine learning, and data analytics will be fundamental in developing AWS. As these technologies mature, they will enhance the autonomy and effectiveness of military systems. 3. Ethical and legal frameworks. The rapid integration of AWS raises critical ethical questions. By 2025, there will likely be a pressing need for international agreements and legal frameworks governing the use of AWS to ensure accountability and adherence to humanitarian principles. Challenges and risks. Accountability in warfare. As AWS operate autonomously, determining accountability for actions taken by these systems will be a significant challenge. This could lead to legal and ethical dilemmas in military operations. Escalation of conflicts. The ease of deployment and operational efficiency of AWS may encourage military engagements, potentially leading to conflicts escalating faster than before. Cybersecurity threats. As AWS become more integrated into military operations, they will also become targets for cyber attacks, necessitating robust cybersecurity measures to protect these systems from adversaries. Conclusion. The integration of autonomous weapon systems by 2025 represents a transformative shift in military strategy and operations. The success of this integration will depend on advancements in technology, ethical considerations, and the establishment of effective human-machine collaborations. As nations invest in AWS, the implications for global security, warfare, and international relations will be profound, necessitating ongoing dialogue and regulation to navigate the complexities of autonomous warfare.